Alrighty. Happy Wednesday, everybody. We are still carrying on with the object system, but we renamed it to Mesh Renderer System, by the way, because we've decided we're going to have... So previously in the original Vulkan engine that we had object data buffer, which represented, it was just the model matrices, but also the material data for all of our, every single object we had in the game. But now we're going to divide it into mesh renderer buffers. They're just going to have the object matrices for the mesh renderer, the model matrices for the mesh renderer, and then we're going to have a separate one for skinned renderers. And we're going to try, we're still doing something called bindless rendering, where we're just plopping all the data on the GPU all at once, but we're going to be a little bit cleverer about it this time around and try to be decisive about what we plop on the GPU all at once, because by far the biggest bottleneck before was definitely trying to map 100,000 model matrices once per frame. So I think where I left off, I was writing unit tests for the CPU side of the mesh renderer buffer resource, and since then I've added the actual GPU buffer side of the house, and we are almost there. However, we were getting into some problems because we are using Diligent. That's the big change. So previously I had written a Vulkan renderer just completely from scratch, essentially just tutorial hopping, because I'd never written a graph. I didn't know a thing about graphics programming, and rather than writing an OpenGL engine like the sensible person would do, I decided that, well, if I'm going to invest the time to write an engine, I might as well write it in a modern language or in a modern API so that I can make use of the best features, not knowing what the best features were, of course. But it took about 4 years, 3 years, something like that. And it works fine, but we were in the Pirate Software Game Jam in January of this year, and we were able to make a game with the engine, which was surprising and awesome and really gratifying, but ran into a bunch of stuff. And I'm finding that because I didn't know what a graphics engine should look like, or really anything about graphics programming, and jumped right into Vulkan, we have this deep-seated architecture that's very hard to refactor. And this time around, now that I know what things like buffers are, and the memory model of the GPU and the CPU, I think I'll have a much easier time around. But we looked into, should we write it in D3, D12, should we write it in Vulkan, because we're targeting Linux and Windows. So originally the plan was, let's try to find an abstraction layer that does all the dirty work for us of detecting what platform you're on, detecting what your device feature set is, etc., so it can be responsive to at least posting error messages. So say we want to try mesh shading, but your GPU doesn't support mesh shading, your driver doesn't yet, then instead of just crashing like we would have done in the previous version, I wanted to see if someone else had done that dirty work for us. And so we're looking at different abstraction layer libraries that we could pull in, and I found one called Diligent, which is phenomenal so far. And so Diligent, as far as I know from looking into it, it's not necessarily a graphics engine. It is called the Diligent engine, but what it is it's just an abstraction layer that it's written most similar to D3, D12, but it allows you to write API agnostic code that's also platform agnostic, which is the coolest. So it's modeled most closely after the D3, D12 library API, so I'm having a little bit of trouble mapping concepts because I don't even really know OpenGL all that well. I just know Vulkan, but so far it's been pretty smooth sailing. I don't remember why I started talking about that. Oh yeah, so we are migrating our entire graphics over from Vulkan, the homespun Vulkan renderer, to a much lighter, much fewer lines of code, Diligent abstraction. And we're being pretty specific. We're not making it as generic as we possibly could right now because we're racing to make a game. We've been building this engine since 2019, so we're ready to make a game, and we don't want to spend a lot of time investing in making a general purpose renderer like we did before. We just want to make one that'll do exactly what we need for the game that we have in mind. So that's the plan. And I'm working right now on the mesh renderer buffer like I had started talking about, and all of this is going to do is it's just a buffer that's going to map. It's going to pull the model transform out of our entities and just map it to a giant buffer that we can bind once per frame. And from there, we can have all of that data ready for us in the shader. So easy enough. Now, when I was running this yesterday, maybe the night before, I was finding that we've got the CPU side set up, which just parses the transform out of the entity and throws it in a temporary vector and then maps that vector over. And now I've just finished the GPU side. And when I run it, if we run in Vulkan, it looks reasonably like what I would expect it to look like. Let's check that here. But if I run it in D3 or D12, it looks as if none of the model matrices are actually being applied. So that's what I was going to investigate today. So here's our config. And thanks to Diligent, we have this handy dandy API toggle now. So let's try with Vulkan. I'm hoping that this isn't too big of an issue. I'm expecting that I'm passing some kind of wrong setting to the buffer that Vulkan's forgiving, but that D3, D12 isn't. Okay. So this may look like hot garbage if you don't know what the scene looked like back in the Vulkan renderer. This is our physics test scene. And this is actually what it should look like, more or less. We don't have our materials plugged in yet. So this is just grabbing a random, well, I don't think it's random anymore, but it's grabbing the base color, which we use just a uint of view into our texture array buffer for each of the objects. Oh, clicking's working. Okay, we're getting there. And then it's just grabbing the model matrix from each of our objects, but there's definitely some work to do here. The camera's very dizzying. We're looking at the scene from a wacky bird's eye view, but the objects are where I expect them to be in Vulkan. So now let's pull up D3, D12. But if you're looking for a library that provides a lot of the boilerplate required to get up and running writing a graphics engine, I highly recommend Diligent Engine. It's been working really well for us so far. And it's free and open source. I think you have to buy a license if you want to do a Mac Molten VK, but we are not supporting Mac at this juncture. Yeah, so this is D3, D12, and it looks as if my model matrices just aren't being applied. And I don't believe I have any errors here, because everything seems to be rendered about the origin. It's odd that I'm not getting any errors, but the best way to figure out why something isn't behaving like how you want it to is to look at render doc. So I'm first going to look at it in Vulkan so I can establish a baseline of what I think the buffer should be looking like. Then once I get this bug fixed, the last thing I need to do for the mesh renderer buffer is, I think it was on stream, I had done a bunch of work to sort our static mesh renderers into the beginning of the bucket that we send over to the GPU, and then the dynamic mesh renderers to the end. And that was just to save on CPU time so that we don't have to interrogate the matrix or the model matrix out of every entity. We can only do the dynamic ones, and I think there will be a fair bit of static ones, so we can just skip that, cache all the static entities, and then join the vectors and send them over, which will save us quite a bit of CPU time. But I was talking to Cal today, and he said, you know, the real win from this is that on the GPU side, we don't have to send the entire bucket over. We can just send the dynamic renderers because we could just map the dynamic renderers over because we've already mapped the static ones to the beginning of the buffer, and that makes a whole lot of sense. So I'm going to be making that change as well once I get this bug fixed. Okay. So this is our Vulkan version, and let's snap a frame and take a look. We only have a single color pass right now. Let's just grab one of our draw calls. It really doesn't matter what, because we're doing bindless rendering, so the entire object in the mesh renderer buffer is already mapped. And what I want to do is I want to take a look at what that actually looks like here. Where are the... We want to go to component. There we go. That's what I was looking for. Okay, so we've got, let's just grab a couple samples here. Maybe the first. You can't. Surely you can copy multiple. All right, let's just make a temp bucket. So I'm just trying to grab a couple samples of what the data in the buffer looks like in Vulkan, so I can compare when I look at the D3, D12 buffer. Jump into temp, we'll call this index 0. And then let's hit like index 17. Actually, it'd be a heck of a lot easier if I just keep 2 instances of RenderDoc going. If you do anything Graphicsy at all, I highly recommend RenderDoc if you haven't ever played around with it. I think it's pretty industry de facto standard to use, but wow. I don't think I discovered RenderDoc for at least 2 years of trying to write a Vulkan renderer. I thought you just couldn't debug. You had to try to noodle out what every bug was before I discovered RenderDoc. I think I'm a champion of doing things the hard way. Just endless grit fueling me on all the time. Oh, we should install. So now that we're cutting over to Diligent, I'm still trying to get my head around Diligent's API and also trying to get my head around how D3, D12 works, because Diligent, their API most closely models D3, D12. They have things like structured buffer instead of storage buffer, and SRV, which I'm still not entirely sure what that is, and UAV, which I think is read-write access. It's a buffer with read-write access. But okay. So we're making our way. Really doesn't matter what draw call I pick here, but let's be complete about it. Oh, I wonder if it's a row major, column major thing. It doesn't look to be precisely that. One thing I've never understood is this even a valid question? Some of these are questions like these even valid? Is row major, column major order even a property of D3, D12, or is it a property of GLSL, HLSL, or is it a property of whatever math library we're using? I've never quite understood that. This is Fabian Gießen. It is. Super cool. He'll tell me. Okay. And so this actually doesn't, this first sentence, GL, does he mean GLSL or OpenGL, or is it one and the same? Okay, so GL, I'm assuming OpenGL is column major storage and column vectors. D3D was row major and row vectors, and they're fixed function pipelines. Let's look at a diligent tutorial here and see. here. Has a model matrix by this tutorial. That's not what we want. Why are they different? Oh, it's definitely a row major, column major order thing. Which one are you? Are you okay? So if Vulkan, we want to transpose. Well, I guess if D3, D12, we want to transpose. But that is odd. I really don't want any API specific ifs beyond Diligent Engine. Let's see what he recommends here. And by he, I mean the creator of the Diligent library. I've been doing a lot of this lately. Transpose. Okay, I wonder if it's a function of the different shader compilers used to generate the code. So if you want to be able to write an API agnostic shader, you can do that in Diligent, but you must do it in HLSL, which also is unfortunately new to me because I'm a GLSL gal. But now I'm guessing that, I don't know the name of the HLSL compiler for D3D, but I'm guessing that, and I don't even know what you call the bytecode. I should really find that out. But I'm guessing that the compiler that generates SPIRV for Vulkan is expecting them to be either row major or column major, and vice versa. But dang, I really don't want to have to transpose based on API type. But that, if that's the case, he would definitely have an example here. this is our ticket. Now we're getting somewhere. Aha! We found it. That's actually really not the worst. So we need to get, is it a GL device though, but that doesn't seem right because, well, A, we're only using Vulkan and D3D12, but I wonder if this returns true in other cases. Odd, odd, odd. So in, oh shoot, we don't even use, no, we can put it here for now. So I'm going to capture whether or not this is a D3D device, which I really didn't want to have to do, but that's okay. Here we are. It's D3D12. Generally, I like to follow the rule that if you have an acronym and it's greater than 2 characters, I think it looks nicer if you lowercase everything, but I've never encountered the dreaded number, so we're going to break the rules. Device. It's context. Device is, what were you again? Device, get device info. The pointer type? No. Neither are you. It's D3D device. got to copy the entire list to a vector every frame in order to do this. That no. Surely the move is just to do it in the object system, the mesh render buffer system, CPU side. But unfortunately, okay, you know, let's just pull it from the config, because we don't have access to any backend stuff here. This is a front-end system, so we're trying to keep anything that requires a device or a context out of our front end. All right, quick bio break and then I'll be back. Okay. Now it's week 2 of these headphones and I've bent them a lot, but still they are quite painful. All right, so when we left off, I was griping about having to pass my first API flag outside of our diligent engine, because that was a contract I was trying to abide by, because that would be nice, but that's okay. So we're going to pass our graphics settings object from the config. Spacing config, maybe. Should definitely have to include you. Where are you? Engine utility, maybe. No, config. Oh, there's more than one way to skin a cat. Where do you live? Oh, just config. Okay, then we can forward declare hue. Won't need you anymore because we're going to delete you one step earlier. Okay, so I'm going to do the transposing in the case of D3, D12, but I'm going to do it on the CPU side when we actually are already looking at each entity to avoid having to map another vector and copy the entire list and then iterate through each of them, transposing and then saving them back. But that means that we need to get the chosen API out of graphics settings, which is, it already is in there in the config, but I was hoping that we wouldn't have to ever care what API you are outside of the scope of our Diligent Engine wrapper class. Okay. I'm yawning. I don't even know if you are in the config namespace. Yes. Did we save the... That's not our graphics types. Curious if we saved our API strings as hard-coded. I thought we did. Where did I do that? Oh, just in NC graphics. Okay. Okay, surely we have a function in DirectX to transpose. Oh, gotta capture it. You are. Now I've got to look up how to capture a member variable in a lambda. Do I just have to pass this? Oh, I like that better. Kind of marginally. I don't need to worry about references because it's a bool. Yeah. I'm being told by the compiler that if I add a parameter to a constructor, I should add that parameter to the caller of the constructor. We're going to want to pop this guy in both overloads because this has nothing to do with whether or not we sort static. Oh, unlucky. We don't have our graphics settings passed in here. Oh, the tests. I keep yawning. It's extremely cozy in this room. I think that's why. Okay, so now that's hooked up, let's get the other transposing in where we need it to. I'm going to make this a helper function. This will probably get extracted to a utility function here pretty soon, but I absolutely love making helper functions. What did I call you? That is so much nicer. It is 10 out of 10 cozy in here. I'm streaming from my bed, and my bed is right over the heater, so my feet are crackly and warm, and it's something like 40 degrees outside and rainy, so it's just the best. What I need to do is find some music for the background of my stream. Oh, that did not do it. Why? Well, let's figure out why. Trying to take this up with, well, let's check Vulkan, make sure I didn't get the logic backwards. It doesn't appear that I did, but this is fishy anyway because I don't see in any examples this being necessary unless it's OpenGL, which we're not using. But let's take a look under the hood. The model matrices are clearly transposed across API boundaries, so this should do it. Checking Vulkan, make sure I didn't transpose in the wrong direction. No. Yeah, that's what we want to see. Let's go back to D3, D12 so I can get RenderDoc launching that instance. The only thing about the crackly heater in here is that my eyes are really dry. Ooh. All right, so let's take a look at the D3, D12 buffer now that we've presumably done the transposing. Okay, you've been successfully transposed. Now, isn't that fishy? Let's make sure you really, yeah, you're the Vulkan. Isn't that fishy? So the buffers are the same. We would also have to transpose our camera. That's an environment resource. What system is handling you? That was a very short-lived anonymous namespace function. Do we have any other kind of utility function here? Our subsystems, we have, no, we don't. I'm gonna pop it in front end for no. Not a subsystem here. And what to name it. Already running into trouble by naming it the same file as in graphics 1. I'm sticking by it. So these are all the public interface includes. These are all the source includes. So let's go and fix that here too. Source, I think you're public. Let's check. Yeah. I don't know what problem you have here. Not finding you. I was. Okay, so if we require a transpose, we can now use our transpose if required function. Okay, let's just test that first, see if it works before we throw it into the default view proj. Because I'm pretty sure that transposing each individual element, each individual matrix, is the same thing as just reversing the order of the multiplication. But what I'm not sure... Why not? Gotta take a break from these blasted headphones every once in a while. Okay, we were trying to figure out why my constructor can't be declared explicit. It shouldn't have anything to do with it being final. I think it has something to do with my config namespace here. Find the namespace config struct graphics settings. Did I have a typo that I missed? I have too many tabs open. I don't think so. Okay, const config graphics settings ampersand forward declare here. Should be perfectly fine. Oh, maybe I don't need explicit here. Probably not. Was that the ticket? Okay, so if we transpose every matrix involved in our shaders. Well, of course, we don't have a, oh, the tests. The tests. Okay. So if I transpose the model matrix, the view matrix, and the projection matrix for D3, D12, I think that's all we need to do. Oh, of course. ODR violation. Go to tests. Make ourselves a friendly. You're in the wrong spot. Friendly CPP. I don't think this is gonna work. I need to find a playlist to put into my stream. Maybe I can do some of Cal's songs, because we need to offset the incredibly long build. I wonder why. Sometimes when I do a CMake install via the CMake extension in VS Code, it finishes configuring and jumps right into a build and an install. And other times it stops after configuring. And that's a productivity sink for me, because sometimes when I'm coding, I'll hit F1 and then I'll go browse the internet or doom scroll for the 15 minutes that it'll take, and I'll come back 15 minutes later and it will just have said configuring done. And then I'll have to start the build and wait again. Aha. Exactly this case. So over the next couple of weeks, we're going to be trying to get feature parity, except that we want kind of a minimum subset. We had a PBR shader in our Vulkan render as well as a Toon shader, and we had a little bit more configurable material system, but it was still very, very hard coded. Actually, it probably wasn't any more configurable, honestly. But we had MIP mapping, which I do think we're going to target, but we're in the race to make a game, so we're trying to, over the next couple of weeks, wrap up any remaining diligent integration work to try to get a graphics engine that's enough of what we need to be able to start working on our game, which I'm really excited about. A link error? No. These are my Achilles heel. Okay. Unresolved external symbol. Transpose if required. In the tests. Tell me it's the tests. I can handle it. It's the tests. That one I know. Okay. I've evolved as a developer, as a C++ developer. Before, a single link error would take me down. And then I evolved past being able to debug most link errors. And then the next phase of C++ evolution was, if it's anything related to do with linking in the unit tests, I'm just done for. But now, for the most part, I can handle those as well, because the only symbols it has access to are the ones that I include in this CMake, because it is a separate executable. And we need to include graphics 2 front end alphabetize graphics utilities .cpp. We need that both here and here. Oh, and now we have to configure again. So I just started book 4 of the Dungeon Crawler Carl series on audiobook. It is so fun. I had seen it, I don't know if it was on X or on Reddit or where I had seen the recommendation, but I saw that it was a lit RPG, and I immediately was disinterested because I thought lit RPG was, I didn't know what it meant, so I assumed it was some fan fiction thing. And no shame on people that like fan fiction, but it's not for me. I don't like anything that doesn't feel precisely like canon. I just feel very put off by that kind of thing. So I avoided the Dungeon Crawler Carl series for a long time. And then I ran out of audiobooks to listen to. And I decided to go for it. And it is so good. So a lit RPG is just a fiction book that has tabletop role-playing game or just any role-playing game-esque elements embedded into the universe. So in Dungeon Crawler Carl, he literally has a video game HUD over his experiences. He's in this alien dungeon crawler game show. But if that puts people off, I would advise you to push past the initial distaste and get into it, because the characters are wonderful. The narration is top notch, and it's really fun, and it's just really good fun book. Oh, that's not good. What do we have here? Now this is going to be a tricky one to debug in RenderDoc, because well, no, it won't. I just need to make sure that the contents of my view proj matrices and my model matrices are exactly the same across Vulkan and D3D. So that's actually not too hard of a task here. Now these we've already checked, but it doesn't hurt. Okay, let's make sure we're in D3D still. Okay. This is Vulkan over here. Yep, those are still good. Now how are we getting the camera is a uniform buffer. Oh, you're still dynamic. Oh, but now we need the frames need to match. Okay, that's a little annoying, but doable. So I wonder, let's do D3D12 first. So we'll relaunch, but we'll just capture the first. Go capture frame, say frame 5. Okay, don't move the camera. You definitely didn't capture. Why? Oh. Okay, don't move the camera. Got it. Now we need to do the same thing with Vulkan, so we need our Vulkan config installed here. Okay, we got it. Now we can compare. Let's hit frame 60. Pipeline state, vertex shader, environment data. Well, surely you could minimize a little. Oh, this is terrible. Oh dear. Well, let's make sure we're not hitting the flow where we're doing the default camera here. Camera subsystem. I wonder, it's gotta be more efficient to just multiply in row major and then transpose to column major rather than transposing each. So I'm going to try. Yeah, let's get rid of all. Oh, I'm transposing twice anyway here. Okay, let's not do that. Then while we're in here, let's just transpose here. I think that was what we were seeing with the absolute garbage was I was transposing the view matrix and then transposing it again before I write it out. But this is the default state in case we don't have the main camera set. I actually don't know which one if we do or not. But I think because we got crazy data when we modify this one that we are in the main camera flow, and I think that we just fixed it. Oh, aren't you, Vulcan? Don't play me like that. I got so excited for a minute. All right. Oh, not great. Okay. Let's just try transposing. I think it's associative. Is that the property? Where I can, so if I multiply these two together in row major and then transpose the product, that is the same thing as transposing and multiplying. But I don't think that's going to fix us, because if it is the same, we didn't actually change anything functionally here. We just got a minor efficiency boost. Why would... I'm going to stab at various combinations of transposing and passing in this shader create info flag. But I'm tired, so I'll probably try to stream a couple more times throughout the week. I'll post something on X if I do. But the plan for the next couple of weeks, I don't think I ever finished talking about that, is I'll be finishing up the mesh renderer subsystem so we can get the model matrices in, and then Cal's working on getting kind of the basics of a simple material system with one shader in. Then after that, I'm going to switch to getting rid of the headless functionality that we had started to stub in because it results in a bug if you try to access the swap chain. And then after that, I'm going to switch to lighting and get just the basic 3 in point light, spotlight. Maybe not even directional light, just point light and spotlight. Probably without shadows for now. Then I'm going to work on some fun stuff. Then I'm going to get into culling. I've been watching a video about how to implement clustered forward shading, and that seems pretty cool. And I think I can get that implemented, and it'll be my first usage of a compute shader, and I'm really excited about that. I can't wait. Then once we're there, we're just about ready to at least start working on a game and see what else we need immediately. Map mapping and anti-aliasing will have to come in there somewhere too. Alright, well, I will see you next time.